The science happens inside this wooden building on the Scripps Institution of Oceanography campus. UC San Diego undergraduate student Ikram Ibrahim got a taste of the project when she was in high school.
It was just a normal tour, and I was leading a bunch of high school students, and they were supposed to be asking the grad students questions.
But she dominated the question and answer session, and her curiosity led to a lab assistant post when she was accepted at UC San Diego.
So it's a very big nerd moment, because I get all excited about it.
Ibrahim stands beside the 30-meter-long tank that nearly stretches the length of this lab building. The flume is designed to recreate what the ocean does naturally.
So we have a gigantic paddle.
The paddle goes back and forth at regular intervals, pushing the water inside the long glass-lined tank. Every push creates a wave that pulses down the narrow channel. That changes when the wave rolls up a ramp about 20 feet from the paddles.
And as it kind of comes up, there's a giant metal ramp that kind of replicates the beachfront as it rises up to the actual beach.
That artificial beach forces the waves to curl and then break.
And once it gets to the actual height of the metal platform, it creates the waves that kind of come crashing, which releases the aerosols that we want to capture.
Aerosols are particles that get trapped in air bubbles pushed down by the crashing wave. The force pushes those bubbles under the water, but they quickly surface, pop, and release trapped particles into the atmosphere. And those tiny particles are what researchers are measuring. Lab manager Christopher Lee says the wave machine is sealed up during experiments, so sophisticated instruments can capture how many particles the wave action creates.
So the purpose of the air ducting that you see on the north end side, as well as the air ducting that goes into the tent and the headspace, is to provide as clean as air as possible.
Lee says running the experiment with very clean air allows scientists to determine how many aerosols are pushed into the atmosphere as the waves churn up the ocean.
It also happens not only on the shoreline, as we are simulating here, but also in the open ocean when the winds are high enough and we're able to generate the white cap.
Principal researcher Kim Prather says the pollution can fill the atmosphere with particles, but dust and sea spray are the two most common sources. Understanding how that system works allows researchers to get a peek at the ocean's role in affecting global climates.
Basically what we were able to do is bring the whole real-world atmosphere ocean into the lab where we could isolate just the parts coming out of the ocean.
Prather wants to understand how many aerosols are created by sea spray because aerosols can help the planet moderate small changes. She says current global climate models aren't sophisticated enough to account for the ocean's influence when the impact could be significant.
So if things start to get too warm, it could change what it's emitting, which will change the clouds and make things cooler. So there's these feedbacks where the natural system is trying to maintain the temperature of our planet.
Prather says the ocean alone can't compensate for the dramatic climate changes that are already underway, but understanding the system gives scientists a sharper view of the future. The next step in their research calls for the construction of a more complex wave machine, which is already underway. That device will allow her team to gauge how other influences impact the ocean.
It'll be winds, we're going to add sunlight, we're going to add human pollution. So now we can start looking at the interactions between humans and the natural system, but in a more controlled way.
Prather says the resulting research will help scientists understand how human activity impacts the planet's climate. She says it could also greatly improve the accuracy of existing climate models. Erik Anderson, KPBS News.